Hello guys, and welcome back to another class of our course about the complete introduction to quantum computing. So in today's class we are still going to talk about mathematics and more precisely linear algebra. So my goal today is to present you three really important properties that are in linear algebra that you guys need to understand. Basically, it's really important if you guys continue in mathematics or if you continue in quantum computing as well. And basically, you will see those properties are pretty simple to understand. I'm not gonna make the whole mathematical explanation about each of those. My goal is really to going straight to the point so you guys understand what exactly is each of those properties. So let's start. Alright, so basically the first property that we are going to talk about today will be linear combination. And what exactly is linear combination? So basically how we can see it as the sum of two vectors that have been scaled by numbers. So in this case, for example, we would have a multiplied by vector a plus b multiplied by vector b. So basically in this case, a will be scaled by the vector a, so as you can see right here. And this is why those two vectors will be in linear combination. What you can do also well, here I gave an example of two vectors, but you can add as much vectors as you want. So basically you can add the vector c, d, e, and etc. The number of vectors that you want. Another example that I can give you, for example, with another type of example would be, for example, the linear combination of x and y. So basically, let's say you have two variables that would be x and y. So basically what's going to happen, you will have the constant a, and let's say, well, you will have a constant multiplied by x plus a constant multiplied by y. So basically you will have two constants multiplied by x and y, and you will have a linear combination between x and y as well. So this would be the first property. The second thing that we are going to talk about would be linear dependence. So basically linear dependence works a little bit with the linear combination. And what we can see right here, for example, in linear dependence, for example, vector a, b, and c will be linear dependent if some vectors, well, let's say you have 3 or 4 vectors, that will be vector a, b, c, d. They will be linear dependent if some vectors of the group can be expressed as a linear combination of other vectors in this group. So let's say we have 3 vectors in our case, so a, b, c. So in this case, let's say a multiplied by vector a plus b multiplied by vector b, we know that this is a linear combination, will be equal to vector c. This would mean that c can be expressed as a linear combination of a and b. So this would be the first part of the operation, and those three vectors would be linearly dependent. So basically, if we take the operation, well, the basic operation right here, we'll know that the vector c will be the linear combination. So basically, linear combination of those two vectors right here multiplied by constants. And basically, this at the end will be, well, this operation right here will do that the three vectors will be linearly dependent. Finally, the last element that we are going to talk about will be linear independence. And what exactly is linear independence? Pretty simple. It's simply the reverse of linear dependence. This simply means that there is no vectors in the group that can be expressed as a linear combination of the other vectors in the group. So if you guys are a little bit lost with this terminology, well, the last one, it's pretty simple. It's pretty much the reverse of linear dependence. So basically it's the complete reverse of linear dependence. This could be a good way for you guys to understand linear independence. So those are the 3 properties that we talked about today. Basically, they're really important in vectors. So basically they work with vectors and in mathematics in general. So we talked today about linear combination, linear dependence, and finally linear independence. And I hope you guys understood the basics of those concepts. So that's it for this class, guys, and see you all in our next class.